In this lesson, we're going to be talking about function rules. And function rules are basically equations with variables such as x and y in them, where you're going to input values into your x and it's going to output values out of your y. So we kind of talked about that when we talked about functions and relations. And we're going to be dealing mostly with function rules that are going to be creating lines on the coordinate plane. These are called linear functions. So before we start learning how to graph these by hand, I would like to show you a really cool skill in the calculator. So what I'd like you to do with your graphing calculator is we're going to focus here on the left-hand side of the page. We're going to go ahead and graph it. So we're going to graph that function rule we have above. So go ahead and press the y equals button. The y equals button is the button that's in the top left-hand corner. You can see that it brings up a screen that says plot 1, plot 2, plot 3, and then a bunch of y's with numbers. We're going to be working in the y sub 1. Your cursor should be there by default. What I'd like you to do is type in the function rule that we're given. So we already represent our y by the y sub 1, but we need to type in x minus 3. Anytime you substitute a variable into your calculator, you have to use the same button. The button is the button that is directly to the right of the alpha button. So locate the green button and then move one space directly to the right. The button should have an X, a T, a theta, and an N on it. Go ahead and click that. That is your variable button. Now go ahead and subtract 3. What you've done is you've plugged the function rule into the graphing calculator so it can read the function. Now go ahead and press the graph button, which is the top right-hand corner button. You can see that it graphed the line that I have here on the page. What it doesn't show you on the graphing calculator, because it's not big enough, is that this line is going to extend in both directions with these little arrows forever and ever and ever. So it'll represent coordinates on that coordinate plane that go in both directions. Okay, so now that we know how to graph that line, let's go ahead and talk about the specific points on the line. Because this line right here, it has an infinite number of points located on it, and they're at specific locations. You can't just go and guess what those locations are. So to do that, we're going to find a table of values. A table of values is a list of x and y coordinates. So here's how we find it on the graphing calculator. We always have to have our function rule in our y sub 1, which we do right now. What I'd like you to do now is press the button second and then graph. The second button is the yellow button and the graph button is in the top right hand corner. You can see that it'll bring up a list of x values and y values, each of them creating a coordinate on this specific function. So if you scroll up and down, you can see that it'll go on and on forever in both directions, representing that infinite number of coordinates. Okay, so what we're going to be doing today is using this information to graph these function rules by hand. Okay, let's go ahead and do that. It says construct the graph of the linear function. Linear just means line. So I'm giving you that this function right here is going to be a line. Later on, we will talk about things that don't create lines, and we'll talk about that in a couple slides. All right, so let's go ahead and look at our function rule. Y equals negative 2x plus 4. What we want to do first is go into our y equals. We want to clear out anything that we were doing in there just by pressing the clear button. And we want to type in negative 2x plus 4 into y sub 1. Remember to use your negative button and not your minus button. Once it's in your y sub 1, go ahead and press second graph. That's going to bring up your table of values. What we're going to do now is just select some of those coordinates to place on our coordinate plane. Now, before we go ahead and select those, take a look at the coordinate plane that I'm giving you. Each of the axes, which is the x and the y axes, in all directions will only go up to 7. So 7 is the highest number that you can put on this graph. You don't want to choose anything higher. What I mean by that is, let's look at the x coordinate. Go ahead and put your cursor on the x coordinate negative 2. Do you see how it corresponds to the y coordinate 8? That would be off of our graph, so we do not want to use that coordinate. But a really good one to use would be negative 1 as our x value and 6 as our y value. So let's go ahead and graph that. Negative 1 and 6. I'm going to put a nice big point right on that coordinate. And then I'm just going to go ahead and choose some other coordinates. How about 0, 4? You can see that I'm just looking at these numbers right off of my table of values in my graphing calculator. I'm just going to keep going. How about 1 and 2? So 1, 2 is going to create another coordinate, and 2, 0 will have another one. You can see that there's a pattern going on with this line, and we're going to talk about that pattern in Unit 4. But I'm just going to go ahead and keep going, plotting these nice points. And I have one more. How about 4 and negative 4? And that'll give it right down here. Now, a really nice thing about graphing the function rules is if you make a mistake, it's really easy to identify. So let's say that we plotted a point that was -1, -3, way over here. Do you see how it doesn't really land on the line? That would indicate to us that, hey, you know what, we made a mistake and we need to go back and double check that. All right, now that we've created all those coordinates, what we're going to do is draw a line through it. So it might be bothering you. Sometimes it bothers me to not stretch all the way across the coordinate plane. So I could even add 5, -6 to tack on that extra point there. I don't know about you, but that kind of bothers me. So now that we have all those coordinates, what we're going to do, using a straight edge or a ruler, we're going to draw a nice line that's going to go right through those points. So as straight as you possibly can, you want to draw that line. And then at the end of that line, you want to draw nice little arrows indicating that that function rule goes on and on forever. If you forget those little arrows, that is quite a problem because that would be a line segment versus a line. So you want to make sure you indicate the right thing. And what you've done is you've graphed the linear function. Now, to check yourself, go ahead on your graphing calculator and just press the graph button. The graph that pops up should look identical to what you see on your coordinate plane that you did by hand. Okay, let's try another one. This is another linear function. Now you can see the linear function here looks a little bit different, but that's okay. Let's go ahead into our graphing calculator and let's go to y equals, and let's clear out any of the contents that are there. And let's go ahead and graph y equals 1/2 x. To indicate 1/2, you can either do 0.5 or you can do 1 divided by 2. Either one is perfectly fine. All right, 1/2 x, and we're going to go find our table of values by selecting second graph. All righty, now we have some nice points to work with. Now, if you scroll up and down, just kind of looking at the coordinate points, you can see that there are some of the coordinates in the y column are fractions. Those points are definitely going to be points that lie on this linear function, but those wouldn't necessarily be the ones that I would select to plot because you're going to be plotting in between two even coordinates, and I usually like to kind of stay away from that. Let me show you what I mean. I'm just going to go ahead and you can scroll up or down. It doesn't matter where you begin. I'm going to go ahead and I'm going to start with, how about -6 and -3? That looks like a really good one to start with. So -6 and -3, I'm going to put a nice dot there. And then you can see right below -6 is -5, -2.5. I'm not going to work with that point just because it's a fraction or it's, decimal. I don't really want to work with that. I'm going to work with nice solid integer numbers. So I'm going to move over to -4 and -2. And again, I'm just getting these right off of my graphing calculator. I'm not doing anything other than that. Now, if I wanted to plot that -5, -2.5, you would see that it would actually land somewhere about right there, which would definitely be a point on the line, but I don't really want to plot something that's in between. All right, I'm going to keep going. The next nice integer coordinate is going to be -2 and -1. You can see the nice pattern. You can probably recognize the pattern at this point. Alrighty, and then we have the nice origin, 0, 0. And we're just going to continue up. Looks like 2, 1 is our next coordinate. And then our last coordinate is going to be 4, 2. Now, again, if it bothers you, I know it bothers me quite a bit. If you recognize that pattern, you can just look in your calculator and you can just extend that pattern so that it goes all the way across your coordinate plane so that it looks really nice. Once you've created all those dots, let's go ahead and draw our nice line with our straight edge. And draw little arrows at the end. It is very important that your arrows extend off of your coordinate plane. For example, you don't want any linear equation looking like this, like that especially, and then you don't want it to look like that either. You want to make sure that it's nice and crystal clear and obvious that it is a linear equation. Alrighty, so those are two examples of how to graph a linear function. Now we're going to look at two examples of how to graph nonlinear functions. So the way that we know that this is nonlinear is this little square right up here, and also that we have two x values. This is actually something called a quadratic that we're going to spend a whole unit on later on in the year talking about quadratics, but for right now I just wanted you to know that it's not going to create a line. So let's go ahead and put it in our graphing calculator. Let's go to y equals and clear all the contents, and let's use our x, and we know how to use the square button from unit 1. So x squared minus 2x. And if you'd like, go ahead and press graph right now and just take a look at what it looks like. You can see that it's a curve. This is called a parabola. And this is the graph of a quadratic. All right, so now let's go ahead and see the table of values. Second graph. If you scroll up and down, you can see that the numbers kind of go in like, I don't know, it's not linear. As one column's going up, the other's not going down. It's they're kind of like swooping up and swooping down. And you'll see what I mean by that in just a moment here. So let's go ahead and just pick some nice points to work with here. This is kind of cool. So let's go ahead and look at, how about -1, 3? That's a good one to start with. -1 and 3. You can see that I didn't choose -2 because it corresponds with 8, and that's just way too big. So -1, 3 is going to be right here on our coordinate plane. And I'm just going to go straight down. 0, 0, that looks like another great one. And then 1, -1 is another one. 1, -1. And what do we have? 2, 0. And keep going. 3, 3. And are there any more? Doesn't look like there are any more because 4, 8 would take us off of the coordinate plane. So you can see here that we don't have anything linear. Oh, and by the way, it's okay that you didn't fill out this down here. It's perfectly fine. But what we're going to do is we're going to create a curve. So we're just going to go ahead and draw in a nice curve and try to be as curvy as you can be. And we're going to put little arrows at the end of our parabola, just like we did our linear equation, because there are many, many more coordinates that are going to fit on that parabola. And that's it. You are all done. All right, I have one more example of a non-linear function for you. And this is a function that has an absolute value in it. And we've seen these before. So let's go ahead and put this in our graphing calculator to get those points. And hopefully you remember from Unit 1, we discussed that, what this looks like in the calculator. And let's go ahead and do that. So what we're going to do is we're going to go to our y equals. All right, and then we're going to go to math. And then, if you remember correctly, we go over to the word num, N-U-M, and it's the first option there. That's absolute value. Alrighty, and what we're going to do is just type in x plus 3. That's it, x plus 3. And if you'd like, you can close those parentheses, or if you have that on your calculator. And go ahead and graph it just to see what it looks like. It looks a little different than the other two that we've been looking at. Absolute values look like a V. And let's go figure out what the coordinates are. So second graph. And let's go ahead and pick some coordinates. Lots to choose from here. Alrighty, how about, I don't know, -3, how about -3, 0? That looks like a good one to start with. And you can test some of these out to see which ones you'd like to start with. And what do we have here? -2, 1. And -1, 2. And you might be noticing a pattern that this side is going to continue to go upward, 0, 3, 1, 4. So let's go figure out the other side. Let's go ahead down to, sorry, that was -1, 2. There we go. Let's go to the other side here. Let's try -5, 2. -5 and 2. And you can even pop, you can see there that negative 4, 1 is one of those coordinates. You can see that it's creating that V shape. And you can continue on if you like. We could do negative 6, 3 if you like. There it is. Alrighty. And you can continue this on you just by scrolling up and down on your calculator. But you can see that it's going to create this really nice V. So I'm going to go ahead and extend my lines with my arrows right off of my page, just like that, to create my absolute value function. Now, we've done everything today in the graphing calculator, and if you'd like to do it by hand, basically I want to just explain what I did. So what's actually happening here is that you are putting in a value for x. It's called an input. And what's happening is you're getting out a y value, which is called an output. So an input and an output. So whatever value that I put in for the x, I'm going to get out for the y. So let's just try a really easy one. What if I put a 1 in for x? So 1 plus 3 would be 4, and the absolute value of 4 is 4. So that would give me an x value of 1 and a y value of 4. Is that going to be on my graph? It absolutely is if my line was straight. But basically that's what's happening is you're putting in an input value and you're getting an output value. And using the graphing calculator is just an easier tool to help you do that. All right, so knowing that concept, let's go ahead and see if we can answer these questions. They're a little bit different. It says, determine the function given a table of values. So this time I'm given the x's and given the y's. And I'm asked, well, which function rule does it actually represent? So it's basically me looking at the calculator, but kind of hiding what the function rule is. Here would be my method that I would always start with. I would locate where x is 0. Do you notice in this first example where x is 0, y is 8? That's saying that whatever I input into, or anywhere where I put an input is 0, I'm going to output an 8. So I can easily look at these functions and figure that out. So if I input 0 into the first one, if I say negative 0 plus 6, that's going to give me an output of 6, which is not our answer. If we look at, I'm going to jump down to C here because I know what the answer is. If I look at C and I say, okay, well, I'm going to put 0 squared plus 1, that's going to output a 1, which is not my 8, so that's not my answer either. Over with D, if I say negative 6 times 0 minus 3, that's going to be negative 3 as my output, which is not my answer. But I can see that in B, if I take negative 2 times 0 plus 8, 8 is going to be my output value. So B is going to be my answer. And I can go ahead and test all of those coordinates that I'm given, and every single one of them will work for the B option here. But let's say you don't have a 0 to work with. Well, then you just want to go ahead and choose any of the coordinates, and you have to go through that same process with all 4. So I like to work with positive numbers personally, so I'm just going to go ahead and I like this one. How about working with the x value of 10 and the y value of 8? Meaning if you input a 10, you should output an 8. So let's go ahead and work it with A. So let's look at this one. Negative 4 times 10. So if I input a 10, that's going to equal negative 40. Now, did that output an 8? No, it output negative 40. So we're going to go ahead and cancel that one out. B, let's go ahead and do 10 squared minus 3. So 10 squared is 100 minus 3, that's 97. That's crazy. How about this one? 2 times 10, that's my input, minus 3. Well, that's going to be 20 minus 3 is 17. That's definitely not going to be my output of 8. And then I have 1/2 of 10 plus 3. So half of 10 is 5, and then 5 plus 3 equals 8, which happens to be my output value. So that's going to be my answer. Now, sometimes they'll give you a tricky function where it actually might look like 2 of the answers are possible, but the only way to figure out which one is the actual one is by testing all of the coordinates. And because basically you can't have two different lines that have the same coordinates. You could have two lines that have one or two coordinates in common, but you're never going to have two lines that are different lines that have every single point in common, because that would make them different lines, so it doesn't work out. Alrighty, so that brings us to the end of our lessons on function rules.